Finally, in this chapter 4.8, triangles and coordinate proof. And coordinate proof is your vocabulary today. What's the difference between your coordinate proof and coordinate geometry? Now it doesn't always, when you're talking about coordinates, it's not always two given numbers. Sometimes you're given numbers, sometimes you're given letters. You are going to do the distance formula, you're going to do the slope formula identically as you would normally do. This time though, you're going to use letters for some of the x's and some of the y's. Here's what I mean. If you have a look at this example 1, in M, the y coordinate is the letter A, and the p coordinate, as far as the p coordinate is concerned, the x part of it is a letter B. So, you know, you're not going to get any definite answers as far as looking for numbers. You're going to do distance formula on both of them. But eventually you're going to finish up with something minus a squared or something minus b squared, etc. Okay, so here's question number 1. Position and label each triangle on a coordinate plane. Best thing to do, always use 0, 0. If you use 0, 0, you're good to go. Okay, you're going to draw a triangle that's ABC, so that AC is 2A long and AB is 2B long. While working on that definition, you know that this guy here, the origin, must be A, because you use A in both A and B. Well, you know that AC is too long and AB is too long, so you know you're going to have an isosceles right, and it really doesn't matter which way you do it, but I'm going to do ABC this way. Okay, AB is 2B units long. Okay, so what are we going? So this is 2B, so we're looking at this. So our coordinate is 2B and 0. So this guy is 0 and 2A. It's complicated, so take your time, all right? Make sure you draw the diagram. It will help you come up with all the possible scenarios. Okay, when you do questions like in example 2, look for things that they tell you, those little golden nuggets. For a start, it's an isosceles triangle, so you know by definition that this and this side must be congruent to each other, all right? And it tells you here, like I said in the last slide, position at 0, 0. Well, this coordinate is 0, 0. The z coordinate, they've already given you an A. Well, what's the question mark in this case? Well, that's the the y coordinate. Well, it's not shifting up any, so it's got to be 0. Okay, so don't forget, if on an isosceles triangle you've got two sides that are congruent, so should also be your two angles. So this guy must bisect this distance. So as far as your x is concerned, it's going to be A divided by 2. Okay, and don't forget your B coordinate. You haven't been given any actual numbers, so it's just B. So your coordinates for Z is A, 0. Your coordinates for Y is A divided by 2, B. Okay, so here's question number 3. We've got the little signs that says that this is an isosceles triangle, which means that the distances from here to here, which in this case is negative 2a, this distance must also be congruent. So that means that t is, if this is negative 2a, then t must be 2a and 0. Because don't forget, your second question mark here is the y-axis. It's not moving up at all, so that's the answer to it, 2a, 0. So the big one to get students, the coordinate proof, and this is the midpoint section 1. Okay, so you want S, which is the midpoint of these two guys. Okay, obviously all the information is down here, and then don't forget you've got to do C and B, and you've got that information down here. But look at what you're going to finish up with as far as your midpoints are concerned. So be very careful when you start using letters as far as coordinates are concerned. So here's question number 5. Let me start you off on this one. Write a coordinate proof to show that the triangle on the right is congruent to the triangle on the left. Distance formula on all of these. Okay, so and it doesn't matter where you start. For instance, you could start DC. Don't forget the distance formula. It must be so x2 minus x1, and again it doesn't matter which way you do it, but I'm going to do negative a, and it's minus negative a, and you're going to square that plus, let me do it a bit longer. Okay, and here you've got plus b minus 0 squared. Okay, squared. So what have you got here? These two guys will cancel out. And what have you got? B minus 0 squared. So you're going to finish up with b squared. And the square root of b squared will just purely and simply give you b. Do the same for GH. And then you've got to do the same for the rest. So DF and GF, CF and HF. And if you've got the same answers, you've proved that they are congruent by the side theorem. So here's example 4, real life. Here they're talking about the Bermuda Triangle, but to be quite honest, the moment you're talking about triangular things, you could start looking at your cell phones from 3 towers. It's exactly the same thing. But again, don't forget, what are you doing? You're doing the three different distance formulas. So each length is different size in respect, because this is 17.33, this one's 15.93 and 14.96. It is a scalene. It's asking you right at the beginning, prove that it is scalene. Well, because you've got 3 different lengths, you know it's scalene. So even though here you're using decimals, it really doesn't make any difference. Here you're using your mapping coordinates. Okay, so let's start you off on a question number 6, and again look at what you've got. It says the flag is 4 feet by 6 feet, so you know that this is 4 feet here, this is 6 feet up here. What does it tell you? Point B bisects the bottom of the flag, so you know that this is congruent to that. Okay, you know that this is 4 feet also, so these two guys must also be congruent. So each of these are 3. So let's have a look at what we've got. We've actually got 2 right-angled triangles here, and it's a 3, 4, 5 triangle. So this guy must be 5, so this guy must be 5, and you have proved here that these are also congruent. But congruent by what? Well, okay, if we look at the actual shape now, what it's actually talking about. So this guy is a 6 by 5 by 5 triangle, so it's an isosceles.